The numbers we deal with in chemistry often come from measurements. A measurement like this one, for instance, where there's a cylinder with water in it, and I can ask you, for instance, how much water is in the cylinder. It will be a measurement. And you would look at the tick marks and determine how many milliliters are in there. In this case, you see a reading of 50, 51, 52. So 52, and then it becomes a little uncertain. So for instance, 52.8. That means this last number, 8, is subject to error. So this discussion makes clear that not every number is equally significant in a number that results from a measurement. For instance, 5 and 2 are significant. 8 is less significant. It's not really accurate. It's an estimation. So we need to have some kind of convention to deal with numbers, some kind of notation that tells us how many significant figures are in a particular number. And we have such a convention. It's called the convention of significant figures. So let me introduce you to that convention. If I give you a number and ask you how many significant figures does the number have, then all non-zero integers count as a significant figure. Rule number 2. If that number has zeros in it, then there are 3 possibilities. First, if the zeros are so-called leading zeros, like 0.002, then they do not count as a significant figure. So in this particular case, 0.002 only has one significant figure, which is the non-zero integer 2. If you have a number like this number here, where the zeros are sandwiched between 2 non-zero integers, they're called captive zeros, then you do count them as a significant figure. So in this particular number here, I count 6 digits. They're all significant, so this number has 6 significant figures. If the zeros appear as trailing zeros, then the trailing zeros are counted as significant behind the decimal point. So in this number here, 1.00 has 3 significant figures. The 1 and the 2 zeros are all significant. Finally, if you deal with exact numbers, like for instance a fraction, 3/4, or pi, these numbers are infinitely precise and have an infinite amount of significant figures. So these numbers will never be a limiting factor in calculations. Let's do a couple of quick examples. Let's take this number here, 123.00. How many significant figures does it have? The 1, 2, and 3 are significant, and the 2 zeros are also significant because they appear after a decimal point. So this one has 5 significant figures. How about this number here, 0.0234? This one has leading zeros. The leading zeros do not count. The 2, 3, and 4 do count. Those are 3 digits, so this one has 3 significant figures. So let's next consider how to do mathematical operations with numbers that carry a certain amount of significant figures. Let's say I do a multiplication or a division, and after this operation I get a result. How many significant figures does the result have? I need a rule for that. And the rule is given here in case of a multiplication and a division. The result has the same amount of significant figures as the measurement with the least amount of significant figures. Okay, so let's say if I multiply 2 numbers, let's say these 2, the first number has 3 significant figures, the second number has only 2. Your calculator will say, if you multiply these 2 numbers, that the answer is 7.12, which is 3 significant figures. However, the result should be expressed in only 2, because 2.0 only has 2 significant figures, and the answer should be expressed in the same amount of significant figures as the least precise measurement in the calculation. So the final answer should be written as follows, 7.1. Now it's expressed in the correct number of significant figures. Now if you do an addition or a subtraction, the rule is slightly different from the rule that we applied above. In this case, the result should be expressed with the same amount of decimal places as the least precise measurement in your calculation. What does that mean? Well, let's look at this. Here I try to add up 3 numbers. Each number has a different amount of significant figures. The first one has 4, the second one has 2, and the third one has 4. The second number here, 3.8, only has one decimal place. That means that the answer here given by your calculator should also be expressed as a number that only has one decimal place. So in this case, the correct answer should be written as 18.9. So I have to remove a couple of digits here. So let's now turn to the next important issue. If you have to remove digits from your number, how do you do that? That process is called rounding. And the first rule that we have to apply here is that we only apply rounding after we complete the calculation. Not halfway through the calculation, but only after we complete the mathematical operation. After you complete the operation, you round as follows. You stick to these rules here. If the last digit to be removed is less than 5, then the preceding digit stays the same. If the last digit to be removed is more than 5, then we raise the preceding digit by 1. That's it. So let's put this into an example. For instance, I can ask you to round this number to one significant figure, the number 2098.765. If you have to round this to one significant figure, then we can write this in scientific notation as 2 times 10 to the third. Only one digit remains. Now if I ask you to round this to two significant figures, you'll find the following. 2.1 times 10 to the third. Why is that? Because the last digit to be removed is a 9, which is more than 5. That means the preceding digit is going to be raised by 1. So 2.1 times 10 to the third. Next, three significant figures. What is that? 2.10. Why is that? Because the last digit to be removed is an 8. That's more than 5. Which means that the preceding digit, which is a 9, is going to be raised by 1. It becomes 10. 2.10 times 10 to the third is the correct answer here. Four significant figures would be 2.099. That's because the last digit to be removed is a 7, which is more than 5. That's raising the preceding digit, which is an 8, by 1. That becomes a 9. So the correct answer here is 2.099 times 10 to the third. So let's apply this technique of significant figures to a couple of calculations. For instance, let's start with an addition. I'm going to add two numbers here. The first number here has 6 significant figures and 3 decimal places. The second figure has 3 significant figures and 2 decimal places. If you punch these numbers into your calculator will tell you that the answer is this, which has 6 significant figures. But we have to ask ourselves which of these numbers, which of these digits are actually significant. The rule is that we have to look at the amount of decimal places of the least precise measurement. In this case, 1.30 has 2 decimal places. That means the answer also should have 2 decimal places. So I have to remove some digits. In this case, one digit, the last digit, is going to be removed. The last digit is a 7, which is more than 5, which means the preceding digit is going to be raised. The final answer is 152.68. Next, let's look at a subtraction. I'm subtracting 2 numbers here. The first number has 1 decimal place. The second number has 2 decimal places. That means that the result should be expressed in a number that has only 1 decimal place. The same amount of decimal places as the least precise measurement in my calculation. Your calculator will tell you that the answer is 8.47. However, we should remove the last digit to arrive at 8.5. The last digit to be removed was a 7, which is more than 5. So the last digit here, the preceding digit, is going to be 5, 8.5. Third, a multiplication. In this case, the first number has 4 significant figures. The second number has also 4 significant figures, which implies that the answer should be given in 4 significant figures as well. Your calculator will give you a lot more figures. We just have to make sure that we remove the correct number of digits from this result. The last 4 digits have to be removed, and the last digit to be removed is more than 5, which means the preceding digit is going to be raised by 1. The answer in this case, 1,349. In scientific notation, this would be 1.349 times 10 to the third. Let's look at the last example, a division. The first number here is having 5 significant figures. The second number has 3 significant figures. The rule is for a division that the result should be expressed in the same amount of significant figures as the least precise measurement, which in this case is the second number. That one has 3 significant figures. The calculator tells you something else. It gives you a lot of digits. We have to make sure that the final answer is going to be expressed in 3 significant figures. I've removed the digits, and the last digit to be removed is a number smaller than 5. That means that the final number here is going to be 11.4.